Section 3.4 in our books describes classifying triangles and then several aspects of triangles that are going to be important later on in geometry. So first, we have a couple of things we need to define. First thing being a polygon. A polygon is a geometric figure that is closed and made up of line segments. For example, a square is a polygon. A triangle, a figure such as this one, would not be a polygon because it is not closed. If I continued the segments to close it, we could consider it a polygon. A circle is not a polygon because it is not made up of segments. The curvature makes it a little different from the other figures, and we'll talk more about circles in Chapter 9. A triangle, obviously, is a three-sided polygon, 3 sides and 3 vertices, and also named for the 3 angles. 1, 2, 3. Now, when we classify triangles, there are several things we have to look at. First, we can classify by the angles. If a triangle has all angles less than 90 degrees, that's all of them, it is an acute triangle. So if these angles are 60, 50, and 70, it is an acute triangle because all of those are less than 90. An obtuse triangle has just one angle greater than 90 degrees. Say this one's 110 degrees, and these were, say, 30 and 40. That would be an obtuse triangle. Now, the reason we don't want all angles obtuse is because that wouldn't make a triangle. If we came down here, made an obtuse angle, and made another obtuse angle, these two ends would never meet. So you can only have one obtuse angle. Okay, next, a right triangle, just like an obtuse triangle, only needs one angle, and that's exactly 90 degrees. So if we have a right angle right there, this is a right triangle. All of this should be reviewed from previous classes in middle school, but we need to go over these in case you forget. The next, we can also classify triangles by side measure. That's not to say that it can be classified by either angle or side measure. It can be classified by both. So we could have a triangle that is both right and isosceles. Okay, an isosceles triangle has at least 2 sides congruent, like that. Now, if we say at least, we could have all 3 sides congruent. But that's a special triangle called an equilateral triangle. So obviously an equilateral triangle is a special type of isosceles. That's one of the misconceptions. A lot of people think that an isosceles triangle is exactly 2. And I believe there are even some books in other countries that define it that way, but our book uses isosceles as at least. So an equilateral triangle, all 3 sides congruent, and all the angles are going to be congruent also. We call that term when all angles are equal in something, we say it's equiangular. Okay, so equilateral is all sides congruent, equiangular is all angles congruent. In an equilateral triangle, both are true. Okay, a scalene triangle, last one, scalene, no sides are congruent, so they would all have to be different lengths. Okay, and obviously if none of the sides are congruent, then none of the angles are going to be congruent also in a scalene triangle. Now, as I was saying, triangles can be classified by both angle measure and side measure, and usually we put the angle measure first. Now, there are some special cases like equilateral. We wouldn't say acute equilateral because all equilateral angles are acute, but for most of these triangles, for example this one, we use angle measure first, and we say, well, since there's a right angle here, it's a right triangle, and since none of the sides are congruent, it's a right scalene triangle. So that's how we would classify that one. The next triangle, if we look here, we have 2 sides equal, and I believe here this is a pretty big angle right here, so we're going to say it's obtuse, and since we have 2 sides equal, it's isosceles. So that is an obtuse isosceles triangle. All right, very quickly, the parts of a triangle. The sides are the segments that make up the triangle. The vertices are the 3 points where the sides meet. So when we describe a vertex, that's what we're talking about. Now, right triangles and isosceles triangles have some special names we need to remember. For a right triangle, the legs are the 2 segments that make up the 90-degree angle. And the hypotenuse is the longest side. It's across from the 90-degree angle in a right triangle. In an isosceles triangle, we have some similar names here. Here we are at the isosceles triangle. The isosceles triangle has legs also, but in an isosceles triangle, the legs we're referring to are the 2 congruent sides. Okay, those are the legs. We say the vertex angle is the angle where the legs meet. Here's our vertex angle right here. The base is the side that's not a leg, so that would be the base right up here. Now notice the base does not have to be at the bottom, it's just across from the vertex angle right there. And the base angles are these 2 angles right down here. And we're going to find out later, base angles are going to end up being the same. And those are the basics of triangles.